kind of disease this is?
It's a quite fascinating disease. It's a disease that most people know, even though they don't know. It's the horror picture of a worm. It's basically that 1 meter long worm that is emerging from a person, mostly a person's limb, and that then is rolled on a little stick and extracted and it's actually many people know this Aesculap snake rolled on a stick, and that is actually wrong because originally it has been the sign of a worm being rolled. Yeah, so all the pharmacies have the picture, everybody knows the picture, and everybody thinks it's a snake, but it's.
And with what consequences?
If you ask about 2016, where we have the last official data from WHO, it was only 25 people, so it's not many at that time. But if you go back in history, like in the 1980s,
Does the disease still occur?
There is only 3 countries, all in sub-Saharan Africa. That's Chad, it's South Sudan, and it's Ethiopia. And then we also find the disease in the meantime in dogs, and a few dogs. And
who is at risk?
At risk are those people that live in the very extremely remote areas where it's hard to intervene, and also where it's mostly in conflict areas, it's in refugee camps.
How does it spread?
It spreads if an infected person has the worm, and at some point the worm has been growing, is long enough, and it's a female worm actually, that is the visible one. And normally in a normal life cycle, that worm would then come out of a lower limb, out of the leg, out of the foot. You only realize that you're infected when a blister develops, and that blister is quite painful. And people that have the blister really feel they need to lower their pain in cooling down the leg. They would then, in a remote setting where there's no access to taps or well water, they would probably go to a pond and then put their foot into water to cool down. And that is the coolness, and the water is something the female worm realizes. It breaks through the skin and then releases larvae into the water. And these larvae would then get into a small water flea, a copepod, tiny, develop. And if a person then, again in a remote area where there's no clean drinking water, is fetching water from that pond or lake, then they would drink this unfiltered water, they would drink the copepod, the copepod would be digested, and then the worm larvae gets free and gets through the wall of, it's not the intestines, it's stomach, through the stomach wall, and then develops for 1 year, grows for 1 year, migrates for 1 year from the stomach to the lower limbs through the tissue, and then again a blister develops and people feel pain, and that's exactly 1 year. So the life cycle of guinea worm really takes a year, and it also uses seasons. So whenever the ponds and rivers are small enough to favor transmission, so that could be in the rainy season in an area where it's very dry, or in the dry season of a wet area. So whenever the pond is small enough that there's a growing population of this copepod, and where the likelihood for the parasite to be transmitted from the human to the copepod and back into the human is high. So,
okay, it's really.
But it also offers it offers possibilities for control or for surveillance, because you would know that, well, if in September there were cases occurring in Chad, then you would only need to go 1 year later and intensify your surveillance. It's the disease or the parasite itself only causes that painful blister, but again we need to think it affects this blister, and the emerging worm happens in very remote areas where people don't have access to healthcare, to disinfection. And whenever you have kind of hole in your skin, there's a high risk of secondary infections with bacteria and with other things. So the pain and the problem is actually rather caused by bacterial secondary infections than the worm itself, because people spend like a day or several days, even weeks, with a wound, with an open wound, and if that is not properly managed, it gets infected, and then it can really cause serious. I mean, some people lost their leg because of it. It causes pain by walking, and again, if we go back to guinea worm, then it's extracting the worm on a little match for as long it takes until that 1 week, and most reports say it's about a week or even 2 weeks. We have seen cases in Togo where they were working with ice cubes to cool down the pain and to activate the worm, and they were emerging within a day. But I've seen that. So it also probably depends on where the worm is sitting, how fat the person is, whether it's easy to pull it through the tissue or. You need to be aware that the worm might be transmitted in the pond you're drinking water from. So either you're using a safe water source if you have a tap or a well, or there's the possibility to filter out this intermediate host, the copper pod. So a simple measure would be a cotton filter and then pour the water through that cotton, because the intermediate host is big enough to get stuck on the filter, and if you then drink the filtered water, that's a possibility of if you know that there's a case in your village, that person should by no means enter the pond or river, because that is then a risk of transmission, and you could then of course also prevent other people from transmission in kind of letting them know they should not favor transmission and stepping into a river and cooling their legs in the pond, but rather use a bucket. So that's called case containment, and there's even hospitals in containment. And then another measure of control, but that's not a personal protection, but again in general would also be to kill the intermediate host. So that's a measure, and their treatment called abate. In the meantime, I would say the biggest challenges is the mobility of people and the civil unrest, the inaccessibility of places where these cases, if cases occur, can be found and contained. So and that's exactly a problem in South Sudan or also in Chad, that it's really and the second challenge is that in the meantime, at least in Chad, there's also this observation that the disease now occurs in dogs, which means in Mali as well, even baboons, the disease was found. And if that really adds into the transmission to humans, then it's a zoonosis, and then it's becoming really challenging to control the disease. Or even, in guinea worm, it's not even control or elimination, it's eradication. It's a worldwide extinction. In guinea worm, because it's really a flagship for eradication, and that's really to point out. I mean, it could be the first disease after smallpox, together with jaws, that is eradicated. It's disappearing from the world, and that is quite attractive for organizations to invest into the surveillance. It's also attractive for the country to be certified of being free of guinea worm disease. So I would say the funding might be into research. So if you talk about research, but I think for eradication and for the control and surveillance, there's really a lot in place to find these 25 or even less or potentially more cases next year. So the countries, the ministries of health have good surveillance systems, and then there's other again, if we talk about the disease, that would be in humans. So there is no medicine to treat humans. I think in former times they tried a few medicines, and that resulted in aberrant worms. So the worm would actually not emerge from the leg, but rather come out of other places which are even less favorable. So there's no treatment for humans against the worm. And again, you would only notice you're infected when it's coming out of your leg, and then the treatment is to pull it. Yeah, there is. It's also research that really focuses on going down the last mile, on the end game. It's operational research that focuses on transmission in dogs and in humans. So, and then there's also more lab-based studies where people try to find out about the whole genome sequence, or whether there's anything where we could trace back from whether a person in South Sudan actually got infected into these studies. I do think, again, because of this eradication flagship, that there is that Carter Center, CDC do their very best in really trying to go down the last mile and to find possibility. That is control and elimination research in that sense. And it's also the Gates Foundation in investing in that. I'm not too much into the field knowing whether there's really gaps in funding. I think the WHO regularly convenes meetings, and then there's like a priority list of research that should. I think, it's guinea worm is also an example. So everything we face at the moment with guinea worm and the problems to go down the last mile and to eradicate the disease will sooner or later also become true for other diseases that are on the elimination list, and that is different kind of worms: lymphatic filariasis, schistosomiasis, at some point malaria, and a lot of lessons learned also in terms of cost effectiveness, etc., can be probably learned from guinea worm.